Good morning, everyone. So, I'm Michelle LaRue Bustamante. I am founder of a company called Alliance. We do consulting, and I run a practice for microservices and security. We assemble teams around projects. I'll tell you this because we tend to work with many different microservices platforms over the past few years. Try to, work with customers' preferences, platforms, Azure, Amazon, different orchestration platforms. And in these implementations, I get to work with some of the brightest people that work with event sourcing, products for event sourcing, orchestration platform development, and so on. And I tell you this because in every single implementation that we've done for microservices, for a larger enterprise, let me preface it with that, I have not seen a situation where adding messaging for full audit log history and so on hasn't been a valuable asset. So the emphasis for this talk is to share a little bit about that with you in Goodbye History Tables, Hello Full Audit. So I'm going to talk a little bit about how we get to that understanding, how we try to make that manageable, and what that means to the concept of potentially message streaming and or event sourcing. So, and then some demos, of course. So with that, let's start with my microservices talk saying most people don't need microservices. How about that? But my point really there is that when you do need it, when it does look like a good fit, then every effort involved in messaging and in audits and in full visibility into your logs, of course, is absolutely imperative and invaluable, okay? Just like DevOps is absolutely necessary for any successful microservices deployment. So with that in mind, let's talk about how we got here. And I like to start with Hello World 1992, not because I'm that old, or maybe I am. But, we used to build one big thing and try to compile and walk away, and 5 hours later hope that it was done. And today we have a different picture of Hello World, which looks something like this. We have a little bit of everything, right? There isn't an app you build today that doesn't have, back-end APIs, that doesn't have probably some form of web front-end, back-end, probably SPA, back-end for front-end APIs, or BFFs as they call them, which is always funny to me. Shared APIs that might be called from JavaScript. And then you've got your mobile apps and back-end APIs and your third-party application, partner applications and APIs, and API gateways that help to manage those things and hopefully give you some throttling, sometimes security, although that is questionable. And then we've got, of course, behind all of that, back-end APIs that serve, probably the thrust of business logic behind all of it, probably in a microservices tier if you're going that route. And then async processing, of course. And this is just the tip of the iceberg because, of course, there's machine learning and data science and a bunch of other things we could talk about, too. So it's already complicated. That's Hello World. What about if we sprinkle a little microservice dust on top of that? How bad can it be, right? I mean, we got here for a reason. We started with things like, again, your monolith, your simple one big thing application where everything was co-located and coupled. The new word for coupling is cohesion, but used in a different way. Then we went to client-server applications to decouple data, right? So another layer of decoupling. Then we went to 3-tier for business layer decoupling with data. Then we went to distributed components so that we could decouple and reuse actual binaries. But that was also to help with scale, which of course had a limit because of greedy clients with things like Corba and DCOM. And then we finally got to what we thought was the panacea with SOA, because that gave us distributed, stateless application components over HTTP. And SOAP, of course, had its heyday, but really we could do it with REST as well, right, or HTTP services, and that's typically what we see now. But this idea also introduced the concept of data ownership in a vertical. So the idea that through only the service boundary you were allowed to access data, and there was controls, therefore, around how you get to the data, what you can do with it, and so on. And any other kind of aggregation had to happen at the service tier, in theory. And so with this, we gained some new insights into how we could build distributed systems. But, the vision of SOA and isolation of data behind the service tier wasn't perfect, right? Because it worked really well at the enterprise architect tier. Because there you had things like your ERP and your CRM and your CMS and possibly a workflow orchestration platform like a BizTalk server or something, or you could try to avoid those too. And the idea would be this could really own its own data, right? Because they were whole systems. They were solutions in themselves that really controlled that back end. And if you really needed access to the back end data, of course, you would just go to SQL or Oracle or whatever was back there, against the recommendation of the vendor, of course, because they didn't have a feature you needed. But the idea was you never did that. So this was, your purest view of SOA, right? I own my data behind a set of contracts, and that's the only way in. But when we started building our own solutions for SOA, it kind of got complicated, because now if you think about something like what I might build for a security system, users, profiles, permissions, that starts to look a little complicated because, of course, my data is not as easily isolated behind a boundary like that, even though those might truly be separate services, one for profiles, one for permissions, and one for users and login and things like that. Because the idea would be, I might need to aggregate two of those things, right? I might need to relate my users to profiles and permissions and so on. So in an SOA world, what I called little SOA was really difficult to follow the purest pattern. Unless, of course, you did something like this, which was, the OData viewpoint or data services. And of course, that had no problems at all. For example, performance and aggregation, issues with the ability to aggregate effectively. We didn't run into any issues at all with that. So that was solving all the problems. Hell no. So how about we move on and say, the layers of decoupling that we reached with SOA were pretty good, right? We got to the point where we were decoupling technology platform, where we were able to distribute actual services and boundaries and data, but we didn't quite have the full pass. And that's where we still are sort of looking for that vision of the best possible balance of decoupling, reuse, scale, distribution. And microservices promises to pick up where SOA left off and make some of those things that were difficult there a little bit more attainable, perhaps through principles we follow and introducing other concepts, right? So that's kind of where we've landed, in my viewpoint. And, a few of the microservices architecture goals then that feed this would be things like, producing these services that are, of course, indeed a well-defined set of functionality, but the goal here being business domain. And I think that with SOA, we didn't really think about it as a business domain, right? A bunch of developers or architects got in a room and said, yeah, that looks like a service boundary. And we just had a bunch of technology-focused isolation patterns around data and schemas. And it kind of worked, again, up to that point we reached. And now we've got this alignment with business that gives us maybe a new viewpoint, right, on how we design. And the design step is so absolutely imperative to get to the point that we want to be at, whereby we can actually have services that own their own data and can co-evolve alongside others without interrupting each other. Which means we have to be very flexible about data ownership and how we eventually perhaps project additional views into the data. And so aligning the functionality with the business domain is step one. And again, that is a finessing process around design. We'll talk a little bit about that to lead into the discussion of messages. And again, the idea is to co-evolve. We want business features to co-evolve so that the business people that actually need the features can say, I need this. And the development team and the DevOps team can say, yeah, I can do that, and it's not going to break the whole system. How many people have ever deployed an update to a system and said, I wonder if that'll have regressions? It happens. I don't think I've ever encountered that at all, but yes, of course it happens. So the idea is to try to get away from that problem. And again, the isolation gives us that. So we want to remove barriers also to the development process around this, meaning if there's a team that does Golang and that's a good fit for this implementation and a different backend store, we've got Mongo over here and Cassandra over there and relational data over here, the idea would be it doesn't matter, right? Because that ownership of the implementation of the service and its data is purely isolated from one another, and the feature evolves on its own. And is distributed on its own and has its own DevOps life cycle. So we can now develop with whatever tools make sense, or we can have third-party stuff come in and sit alongside our other services, and that also helps. Updating features then without impact to the other parts of the system is the end goal. DevOps and automation being the thing that makes that possible. So for example, we don't want to be finding out after we're live in production that we don't have a disaster recovery plan, that we don't actually know if updating this service will impact another. And one of the best ways I have found to ensure this, although this is not part of this particular talk, it's still an important data point, is by making sure that your services, the consumers of your services, are the ones that should define the tests. Because the acceptance of the service and what it's supposed to do, that integration intent is really, really important. It's fine for me to say, even, let's talk about a permission library. I want to associate permissions with users. I want to, associate permissions with users per tenant. I want to make sure that this permission is always associated with that role or something along those lines. Those are business rules that get somewhere integrated into the back end of that API, but no matter how well I document it, somebody's going to try to use that in a way I didn't expect. So if they tell me what the integration test is, well, what's going to happen is we're going to log in, we're going to go to this app, we're going to try to access, but because of the tenancy and, oh, by the way, this other entitlement, oh, I didn't think of that, that's how we're going to validate access, and that's how we're going to, lock users out if there's frequent access that's, invalid. So just throwing at you that the actual integration step requires the people that take the services and integrate telling you how they're going to use it, so that the validation of those tests then is provided by them, and then you run that as you build your service to know that you didn't break anybody. That's a lot of work, but if you do it, it's going to work. Otherwise, guess what happens? You get on the phone and you're talking to the people that are integrating, and they're calling you saying, the docs say this, but it's not working. And you're like, well, I didn't know you were going to do that. And then you add it to the docs, and you evolve that over time. So you can either do it ahead or you can do it later. It's going to happen. So continuing then, when we think about our view of Hello World, what we're really looking at doing with this vision of now moving to microservices is a lot of smaller things being deployed, a lot of smaller services that fit in your head, that are a manageable amount of conceptual functionality, and that fit, again, that business domain, that use case, and that can then co-evolve and integrate with other pieces of the system in whatever way makes sense. So each of those services then ideally would own their own data, as we've talked about with SOA, but now potentially making it real. And it becomes real because of things like eventual consistency, which we need to get to. So we want the business to be happy. They're going to say, I want new features. And then what they're going to get is this beautiful picture of, I can update these two things and not affect anybody else. Everyone can agree this is the vision we want to get to. The question is, again, how do we get there? DevOps, automation, really, really well thought out design up front. And with that design, the ability to really align with what the business intentions are. So the concepts that we use to get here then are things like domain-driven design. Again, the concept of services being smaller, fit in your head is a good way to think about it, right? A small team can manage this. And what we'll see as I start talking about messages is it's also really important that it fits in your head, because when we start thinking about all the messages that could apply to one service, and I go through my example, that has to be manageable. And if it is manageable, then it starts to feel really doable to actually build in messaging to all the services once you have some baseline patterns, reusable components, and things. So smaller services, services owning their data, potentially CQRS patterns because of the fact that we want read-optimized views, and also because we're doing eventual consistency, which implies that I'm going to have some views projected from messages, perhaps. eventual consistency is a big part of that then, right? So eventual consistency provides me with my read projections, provides me with my aggregate projections, and so on. And then, of course, backing all of this is message streaming, is the ability to have, message streaming events and full audit of everything that happens in the system. That's the dream. And in a large system that has a lot of workflows, jobs that run at different times, things that maybe the current system does that are hard to follow in terms of what's the state of the system now in this area of the business, in that area of the business, it's completely unmanageable for most people today because they don't actually know, because there's no one view of what's happened, the messages, the logs, and so on. It's the number one thing you can do to surface to the top that data. Even if you don't know how to query it yet, even if you don't have dashboards yet, even if you haven't made it look good and made it easy to get to yet, as long as you're collecting and putting that data, that asset somewhere, then you will be able to build those views and you will be able to get there. And even build perhaps, process managers on top that can say, these messages have happened, therefore I know where we're at on this particular workflow. So it gets really interesting. Of course, again, part of the concepts we care about and you have to continue to emphasize is the DevOps culture, because there's nothing worse than not being able to automate recovery or rolling forward when something goes wrong, and having the ability to, with all these little things running around, have alerts and knowledge of health of the system, which again is outside of the scope of this talk, but still very, very important to the whole concept of deploying a microservices architecture that perhaps lives on an orchestration platform that has self-healing and other types of recovery mechanisms. You want to gather all that data too and make sure that those logs are also surfaced, right? Every bit of data you can get to know we're healthy, and if we're not, how do we recover? So let's talk about design a little bit then. So to get to where I have a manageable size service that I can work with, that I can build messaging around, I need to first go to the design board. And when I work with customers on this type of stuff, it's interesting because, some solutions literally have hundreds of applications, right? And they've got some off-the-shelf products. They've got back-end, mainframe systems still. They've got jobs, cron jobs running all over the place, dropping files, picking up files. Again, all kinds of legacy potential pieces of the puzzle, and then new code that they've written, even new monoliths, right, in the new style, that includes APIs and web and so on. So when we go to the drawing board and try to think, what do we do? I usually take use cases across the various parts of the system. So, this would be an example, say, of some sort of fulfillment, business that has things like ordering online and products and fulfillment and the back end. And, of course, you have customers and maybe recommendations engines. So now we've got things like machine learning in there, right? So the idea is you need to go to the whiteboard. You need to pick out pieces of the system and go through activity diagrams. That's what I usually do. And I'll say, let's get the different business people in the room for how this part works. How does shopping cart work? What kind of features do you care about? How does product ordering work? How do you manage that? Do you do product development? Do you have a warehouse that does stuff? And how do they all communicate together? And you start to go through, say, some use cases of each of these things, and maybe at the end of, say, 2 to 3 days, locked in a room with all these different discussions, you end up with some patterns that evolve. Like, okay, the legacy apps look like this, and the cron jobs look like this, and the COTS products have these issues, like I need to replicate data. And then I've got, some newer applications that are sort of monolithic, but I could start teasing those apart. And you start to see where the problems lie with the business. Now, I didn't say problems with the technology, even though those exist, because the biggest problem you want to solve if you go to microservices is the biggest business problem they have today. Because if you invest a bunch of time in designing and implementing your first go live with this, that 8 months is so painful and so expensive for the business that if they don't get value out of it immediately, they're going to not back the next phase. And all that fun stuff that the technology people got to work on and get their hands in is going to be gone. So the business motivation behind moving to microservices has to come with, I know it's expensive, I know it's going to be hard work, here's where we're going to get to. I'm going to have full visibility over these crazy workflows that right now cause us to call developers on the phone to look at data stores in 5 different places and file drops to find out what's wrong. That's a problem to solve. That's a problem that needs visibility. That's a problem that, you know, if you can surface messages and information and start building visibility into that, you've now made it worth the many hundreds of thousands of dollars that it might cost the company to do the first 8-month launch with 5 services. From there to a perfected, again, disaster recovery, full audit log, automated deployment process, that whole go live perfected to the point where now we can go from 5 services to 20 and to then 100 with less pain. The investment's up front, 100%. Okay? So when we look at this design, right now, this would be sort of a, you know, a hand wave over, okay, here's the basic moving parts that this company has. But I'm probably not done, because what I haven't thought about is single responsibility principle, right? Like, what are the one thing a service should do to do well? And every service in your solution should do one thing really well. That doesn't mean it doesn't coexist with other services that do one thing really well. That's not done really well, but you know, the example is there. If you have one job, it's manageable. That doesn't mean it's one service, right? A microservice can have more than one service in it. That's another misnomer. It depends. What if you have CQRS? I still might have a shared schema on the back, and I still might co-evolve the read and write APIs, but those would go together. Or I could have user identity related things that just always go together in certain systems. Not permissions and identity, but say identity and profile. It could go together, or it could be taken apart, depending how robust working with profile is with this company, with what they do. Do you see? So you have to think about it. Does it make sense to co-evolve it? Does it make sense that it belongs together? And that's where you start. So these are finessing things. I wish I could tell you there's one guide that says here, you know, here's your roadmap, here's how you design, you know, your solution as a microservice architecture. There's principles to follow, but you can get stuck on the principles to the point you don't make decisions. So you have to be prepared to iterate. You have to be prepared to take the time up front to look at the whole system, start taking apart where the big business problems are, then take some of those examples and say, okay, I think we get the idea that if we used a message-based architecture, our pattern could be APIs in the front, APIs in the back, command, query, and also messages, and then we can have a topic that's the general topic that always audits, you know, we get a full audit from, and then we're going to have funnels into services. So you get some patterns out of this. And at the end of that, you can start building out a POC that is going to solve the biggest business problem you have. And that's where you invest your first dollars. So let's take a simple example, identity management. Most people understand identity. I need to log in, I need to log out. I might get locked out if I have an invalid login several times in a row, retries. I might have self-registration, which requires me to confirm my email. So there's processes around creating the user object, around creating a profile, and so on. Now, identity management involves other things. It involves permissions, sometimes entitlements. So now I've taken one box on that and said, well, this is really potentially 4 different services, 4 different microservice, you know, verticals, potentially. For sure, permissions would be separate from identity. That's just something I would say out of experience, and also because they don't belong together. Entitlements could be in itself a huge implementation. I mean, sometimes those are done with XACML and other protocols. Sometimes those are just custom code against a database that looks up ownership, you know. User management and single sign-on being the login, logout, lockout, you know, process around identity, usually in an identity server. These are the things that I have to now look at and say, do they belong together? Do they belong separately? But you see what I'm saying is identity management is not one box. It could be broken out once you start thinking about the business cases. I'm going to evolve permissions completely separately from, user management. User management, I don't know yet. I need to think about it. So it could be that each of those owns their own data. I have users, I have profiles or registrations, I have permissions, and I have entitlements. Loosely put, it's a collection of data behind some services. So those could be 4 microservices. And they're going to be related. So now we have a problem. And the problem is services own data. I can't get to the data without the service, or can I? What's the way that we solve this problem in the post-SOA days? Eventual consistency. So I have users. When I create a user, I might create a profile at the same time. I need to relate them, but they're in different stores behind different services. So how do I decouple the process of getting those things eventually consistent? And usually the way to get that done would be with messages, because then I can somehow have some form of guarantees. And again, that's a whole nother discussion, right? Because there are different ways to achieve, the not ACID, but at least, guarantee of eventual consistency. I don't want to take you there right now, but there's lots of great reading on that with things like Eventuate.io and Event Store as event sourcing models, because those become event stores, but also they're able to publish messages. So they're data store, essentially, events, and also can publish messages as part of a heuristic when you write, and make sure that's a guarantee. So there's things like products like that do those things. So users, profiles, permissions, entitlements, all related. So at some point when I create a user and a profile, eventually those both need to be written, let's just say. Now, when we look at domain-driven design, we think in aggregates. So usually a microservice would own its own aggregate, and it would only write to its aggregate. So user would be an aggregate with login details and user state. Am I logged out? Am I active, inactive? Is my email confirmed? My profile, first, last name, date of birth, all those other things, unrelated, right? Not related to login, nothing to do with signing in, signing out, locking. Has nothing to do with that. That has to do with information about me that maybe shows in the app. Information about me for contacting me, sending me, calling, CRM style, that kind of thing. So my aggregates are clearly separate, but yet they'll be related. So the way that things get related in aggregates is an identifier, right? The idea is that the user ID, of course, will then relate to an ID in the profile, right? So profile will have a relationship back to user ID. But I can still have services that own writing to those, for example. So I could have a user management service. I could have a single sign-in or login service, let's call it. And now I would have ownership of profiles and users. Now it's not perfect, because you can imagine when I create a user or I create a profile, I probably need to create a user too. So now I need an eventually consistent model for both of those things getting created. So I still need the services to own their data, but something to tickle the second service, hey, by the way, you now have a user. And this is where the messages come in. So I'm leading up to a story where I can actually give you a demo, and hopefully this is painting a good picture. When we think about CQRS, we're thinking about the separation of reads and writes and, optimizing for reads. So like my login server, that would be a great example. If I have scale of millions of users, then my user management stuff shouldn't interfere with those optimized reads for getting a user logged in, because people are going to log in a heck of a lot more and request tokens a heck of a lot more than they're going to update their profile and or be managed by the user management, area or UI. So I could have commands that then write to profile and user. Notable that I could have a command, and this is, sort of true of the principles of command query. A command could potentially affect more than one aggregate. How should go through a service boundary, but it can logically affect more than one aggregate. Whereas an event, if you're thinking about an event stream, should only ever talk to one aggregate. And that's where we can get the decoupling when you combine command query with events, because you can have command query trigger messages that then become events that lead to each aggregate. Meaning there's something in the middle here that we'll get to that will end up updating users and profile as a result of a command. So when we think about command query, we're thinking about optimizing for reads. So my user management will read from the eventually consistent projection, which is my read profile store. My read user store for optimized logins would be over here. And so the idea could be that, again, this could be a service or multiple services that own the collection of these, and this aggregate is eventually consistent, or this read store is eventually consistent. This guy can trigger a message that gets to users as well. Make sense? Excuse me 1 second. So, the point here, again, is sort of just to tell you the story that we're leading up to, which is users even are complex with users and profile. We think about a command like create user, and it could lead to updating a user and a profile. So there could be a crossover of the services and the data. And the way to decouple that is messages. Okay, so with that, let's do some work. I'm going to get in here. And so here's what I've got going here. I've got a local Kafka running and a local event store running, which I'll get to in a second part of the demo. So my Kafka container is basically going to be receiving messages for all the users and profile requests. Now, in this example, I'm just going to use one topic, but I want to talk a little bit about aggregate topics in global order as we go. So this is already up and running, and I'm going to go over to my solution. In the solution, what I have here is a few things. So let me kind of close this up. So I have a web app. The web app is my harness for testing messages. So every time I do microservices related message-based solutions, there's a couple of things that have to happen. One, I'm going to design my APIs that are responsible for the business logic processing messages. I'm going to have, obviously, the definition of what are the messages that are triggered, and I'm going to have to build those out based on workflows. Create user has to have a workflow, or a register user, that I have to decide what should that event be. So I'm going to go through that in the form of demo and explain how that sprays into additional messages later. So my web app is going to start with registering a user, and we'll take it from there. So in my web app, I have a registration controller, and we'll hit register when I do so. I have an API on the other side. That API is responsible for the logic post-projection. So my web app's going to send messages, publish. My projector is going to pull messages, consume. And it's going to be responsible for creating the eventually consistent projection of the current user state and the current profile state. And it's going to be responsible for generating other messages that indicate something's been done or something failed. So what I'll do is give it a run. My store is an Azure DocDB. So what we'll see is a NoSQL solution, which is the projection. So I'll let that load. Yeah, this is local, so that's not happening. I think I know what it is. There you go. It's because the app URL isn't set. So when you do multiple project start, it's not set to the right, Kestrel's not set to the right port. So, okay. So what I have now is just the web app running, and it's going to generate messages. So I'll click register, and I'll create a new user. So just for the sake of bumping this up, I'll go to user 10. And I'll create an email, user 10. We'll call it user 10, Busta. So my user is, when I create it, we're going to hit this. So create user async is the, this is the controller. What I'm going to do is step in, and you'll see that it's creating a user registration requested, past tense message. So notice it's not saying user created. I don't know if the email's available. I don't know if the username's available. I could go query the current state and see if it's available, but I could still have a race condition where it still fails. The only way to guarantee that I can access and use that email in this request is if I move over to the event store model, where I'm actually hitting the stream, and the stream is the user, and the stream is named for the user email, and I can guarantee that if I got the stream, I own it. So in other words, you have to think about your messages as what is actually happening. What is the past tense event that I can guarantee just happened? Because every single event means a thing happened. What I did here is I am requesting a user registration. And so if I take a look at the user registration requested message, it's defining first, last, etc. So this is my message. And you'll notice that every message has a base. The base message has an activity identifier, because what I'm going to do is activity tracing all the way through, from my logs through to my messages to the other side. That way, if I see a message that I wasn't expecting and I want to go to my logs in Kibana, I could actually look up the causality all the way through, from the web app to the sending of the message to the API that processed to the writing of the data. Any component that I'm logging from should have the same activity ID for that entire request thread. The other thing I have is a causation, which would be if a message triggers sending other messages, then I will link those. So I can say this message actually triggered a failure message after, or a success, and another couple of messages. So I can actually have that causation, and I can find it. And then, of course, correlation is more like request reply. So if we were doing async to two directions, then I can collect that. So the idea is my messages all have, some common denominator. There's usually other stuff that we're adding in for, production things. This is simple enough. My registration is first, last, email, password, hash. Notice it's hashed. I can't write the password to a message. So my business logic should be in an API up front that knows what our password hashing rules are, and that same component should be the one that's used on login. So there's things we can do to make sure that's shared, like have it be in an API endpoint that's part of this process. But the idea is sometimes there's processing before the message and sometimes there's processing after, and you have to think about that. When should I generate my email confirmation token? Not before I write the message, but after I process it when I'm sure I want to send it. So there's rules for, before and after processing. So in this case, all I'm doing is I'm creating a message saying user registration requested. And if I continue forward, Send message async is really just going to publish to Kafka. Now, of course, this doesn't have to be Kafka. It could be Kinesis in Amazon. It could be Event Hub in Azure. You can use RabbitMQ and others. I tend to prefer the models that have, the topic and, storage 30 plus days, potential replay of messages from multiple consumers and tracking those cursors. And this is just the pattern that I've been using. That doesn't mean it's wrong to go another route. So send message async is going to call producer send. And again, I can have logging throughout within those components. This is just an error because I took too long. So that should have triggered sending the message. The way we're going to know for sure is if we try to process the message, though. Now, right now, my consumer is not running because I didn't actually run all the things yet. And so what we'll notice is if I come over here, I'm not going to have anything in my data collection. So for example, if I just click over here to the Data Explorer, I'm not going to have a collection. I don't have any data just yet because it hasn't been processed, right? So we're waiting for that. Let's go over to this code. And what I'm going to do is I'm going to run the management API because the consumer is going to expect that to be there. And that's the API that didn't run when I was trying to run multiple projects. And then I'm going to run the consumer. So this consumer is going to process messages, and it's looking at this microservice topic. So again, thinking about microservices, I have a solution. It is my microservice. It has an API that is part of the microservice. It projects to a state store that is part of the microservice. It has events that are tied to the microservice. It has a projector that reads topics. The topic is tied to the microservice. And if the microservice fits in your head, small enough to manage, you start to see patterns whereby this vertical is actually easy to manage all the way through and through. Topic, messages, commands, APIs on both sides of the message processing, the messages themselves, commands themselves, I think I said, the projector, right? This is my microservice. And there will be base things that I can reuse across all my microservices when we think about how do I register events? How do I use, what base type should I use for all my events? And all of those things become reusable stuff that help me with activity tracing, audit, and so on. So this one solution then, again, becomes sort of a way to look at the microservice. So when I look at processing the message, what you'll see is my projector, or my consumer, is looking at every message it cares about. It may not care about all of them because sometimes we're looking at an aggregate topic versus a microservice topic. So I could say, I don't care about these messages, but somebody else might. And so we'll get to that in a minute because I have a history consumer that's going to project all the history of everything that happened. So when I look at this, every single message once processed will end up calling the API. So what I'm going to do is start this consumer. So that'll kick off a service, and that will call the API. So here I am now in my user registration requested API endpoint, and it's going to create a new password user and save that to my data store. And if that were to fail, then I'm going to get a failure. But if it succeeds, I'm going to generate a new message for user registration success, and I'm going to generate an email confirmation token and send that over to the user. So now I've got a correlation or a causality, from the first message to two others. So let's go ahead and run it. What I should end up with here, and those errors are okay. Those are just messages we didn't process and I'm not swallowing it. So I'm going to hit refresh. Let me do this. It is preview after all. Somewhere in here. There we go. So I got my user, and you'll notice is confirmed as false. So at the moment, what I have is an eventually consistent user record. I can also generate a profile record from a different message. So right now I'm not breaking that up, but I gave you sort of the visual on where that could go. And what I'm going to do is go over to our UI, where we were, and we'll go ahead and instead of stopping on breakpoint, I'm going to create another user, 11. I'm going to set another password, and we'll call that 11. And this time I'm going to continue more quickly. It's hitting the API, doing the same thing. You'll notice that it advanced me to confirm the email of user 11. So I'm going to go ahead and I'm going to put an invalid token because I've sort of set it up so that I know which one is invalid. So that says confirmation failed. Now I'm going to put a valid token, and we'll go ahead and verify. And it says successful, which means if the projector is running, I should get an update. Let's click this again, and you'll see an update from is confirmed, should be. Let's do this. Oh, I need a new user, excuse me. Let me refresh. Second user coming up. I think I had to click away and click back, so I'll do that again. Okay. Here we go. And the second user. User 11 confirmed is true. Yeah? So I eventually got that message to say update, confirm the user. So let's go ahead and try something else. I'm going to go and log in. User 11. And when we get to login, we're going to hit validate password. So what this is going to illustrate, if we step in, is that I'm actually going against the eventually consistent store to check if the user can log in. Now, this is a very important statement because this is security. And we do this a lot with identity server deployments under Event Store, with Kafka, messaging, and then some that are just no messaging at all. When you're using messaging, you have to make a decision. What is your tolerance for eventual consistency? And so if your tolerance is, we're going to monitor from a DevOps perspective, messages are processing, and if they don't, we'll take that risk, then we can go against the projection. When we use Event Store, we actually go against the stream, so we always know for sure the current state of the user, whether they're locked out or not, whether they're active or not. And so these are decisions you make, right, around eventual consistency and tolerance when you're looking up certain pieces of information. In this case, I'm going against the projection, but I don't have to do that. I could also go against, quote unquote, the message stream and get the absolute truth, because the message stream, if I'm doing pure event sourcing, becomes the source of truth, becomes what's true about the state of all the things. So you need products that help you with that, like Event Store or Eventuate.io, to make that easier. Or you can do fancy stuff with Kafka that replays up to that point, right? So that's a lot of work. Otherwise, you take the eventual consistency story. So that's my point, right? Okay, so I'm validating the password. I'm going against that store. You can see I'm hitting store read, so I'm actually hitting to see if I can log in the user. And if I gave a good password, then I'm authorized, right? So now I'm going to log out, log in again, put a bad password, and this time it should fail, right? And if I try that again with a bad password a couple of times, I'll end up locked out. So I'm going to actually get rid of these breakpoints so we can hit it faster. Let's try again. Get rid of the breakpoint, lock out. Okay. And And at some point, I should reach locked out. So let's go into our data store, click the user again. Unsuccessful attempts, 5. And I'm probably in locked out state, which means that I won't get unlocked until the expiry passes. So after 5 minutes usually is what that's set to. And then I would be able to get in. Okay, so I can do some more things like reset my password, user 11. And what this will do is request a password reset, send a link or an email to the user. I'm going to show you all these messages in a moment because I'm going to go to the history log. So right now, this is just updating my current state, right? If I change my password, then resetting that should get me logged in. Update the password, login successful. No, not yet because I'm still locked out. So the point is that updated my current state. I still have, whatever my state is, my password has now been updated and things like that. But I don't have a sense of audit yet, right? I don't have a sense of what has been going on while I've been using the system. So the projection to eventually consistent state where I have my user store or my profile or even some aggregation of users and other things somewhere else that I might need at some point with a different projection, listening to the same messages or an aggregate of messages. That's still only projecting a state. It doesn't tell me the history. So what I'm going to do is I'm going to turn on my history log. So one of the things that's interesting about working with messages, again, thinking microservice, manageable number of messages, thinking that I've now got data that I've emitted somewhere to Kafka that is there waiting to be processed again by somebody else. So I've processed it to do my current projection of state. I may at some point change how I process the generation of state, and I could go reprocess all of them again and generate a new current state. I can do snapshots to make it faster to get there. But I can also later decide I need to use that data in other ways, like we didn't use all the information in the message to create the user record for login or lockout or active-inactive, but I've got this profile data that's now interesting and maybe some other messages that are related, and I can go process those and project something new. Or in this case, what I'm going to do is turn on the history consumer. So I'm going to go ahead and start my history consumer, which is another projector. It's going to look at the same topic, but this time grab all the messages and produce a history log of the things that happen to the users. So you can see this is processing, a bunch of messages. Registration, success, token sent, registration requested, etc. Yeah? And once it gets through all the messages, I should have produced a history state. So let's go ahead and refresh over here. And now I have a history document, or a set of documents. And each of these is actually a message. So I now have, for example, for user 10, I could say, hey, let's take a look at select star where c dot username equals user 10 and apply the filter. And, oh, that's first name, haha, yeah. So, pair programming, thanks. Username. Sorry, what am I doing wrong? First name. No, I want username, user 10. Yeah. So it gave me just that. Now, what if I say user 11? And what does that give me? Just that. So now I have a bunch of things. But this is a bit hard to read, so what I'm going to do is go over to my Query Explorer. And let's say instead, select star from C, where C dot username equals user 10 or 11. And I think I can do here is say C dot message type. And let's run that query. So now you can see for user 11, I had user registration. I confirmed confirmation failed, confirmation succeeded, login success, user unlocked, login failed, attempts incremented, attempts incremented, attempts incremented, somewhere down here. Actually, it might have been over 5 would have put me over the top for locked. So I guess I didn't reach that. But you see the point. I now have a history which has more information than just the message type. And if I ever needed a history table for the user, I now have it, right? I have everything that could possibly happen to this user. I could aggregate more than just this. I could go to their profile and pull that in. I could go to other topics and pull those in. And now I've got built-in data waiting for me to do something useful with it when I'm ready. So, you know, it's very powerful, the idea that you have this full audit. And furthermore, I can also have full audit of things like unauthorized access to assets, you know, so you're supposed to track things like when you try to access a path and you don't have the permission or you're not logged in. And those are different heuristics. If it's the same IP address, doing machine learning on those things is interesting, but even just having the history, who granted that permission to this user? There's all kinds of things we can go down the road of, but the point is if it's all done with messages and then if you tie that in addition to the messages to your actual logs. So now we get into what if I wanted to look at my logs and tie those together with the messages. So right now, if I take a look at my Cabana logs, I'm actually also shipping the messages up here in addition to shipping up, failures, successes, and other pieces of useful information. And I could come in and find messages that have a type, for example, like let's say, scroll down a bit. Processing message, password, reset token sent. So for example, if I open this guy up, or let's look for register actually. I'm going to go through here and find register. Register is somewhere. Yeah. Login failed, user locked out. Lots of messages. The reason I was looking for, registration created actually, is because what I wanted to do is just take you to, for example, a activity ID or a message identifier. So like, for example, this ID somewhere. Message template. Oh, I see what I have here. This is my fault. I'm going to run my Elastic projector. I have another projector that actually ships up the activity ID correctly because my logs aren't currently doing that. So I guess the main thing I was trying to get to there is that, I can come in and I can find out data of one of these messages, like some identifier, for example, add that up, and then that becomes my filter. So if there's multiple messages that have the same identifier or causality, then I get to see the trend here, but also tie that to the error logs and things like that. So how we usually do that is with a component like a filter that's attached to every single call into APIs, out of APIs to call and write data, every component that matters essentially, every service component. So one last thing I wanted to show you here is how this might apply if I'm using something like Event Store. So I have a simple demo here that just, when I run it, it actually does sort of a contrived workflow. Again, test harness for writing messages. I always test the messages first by looking to see what's the output that I'm going to get in my logs, what's the output when I'm looking and inspecting at the order of the messages and the content of the messages before integrating it to a wider application that actually is where the messages will be sent from, for example, because that's a lot more work for test. So my harness would do things like simulate. I'm signed in. I'm going to hit enter. I'm going to lock out the user by signing in 3 times badly. I'm going to hit enter, and then advance the time 5 minutes so that I can sign in true. And then the end result of that will be that I can come over here and I can look in my event store. And let's come over here and see my stream browser. Probably have a user here and a list of messages. Sign in succeeded, password locked, user locked, sign in failed, 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 and locked. So it's actually in reverse order, registered, succeeded, etc. And then each of these expands into what is the data that was sent in the message. So the idea here is that when I want to know the state of the user for login, I'm actually looking at the whole stream of messages and aggregating that to a state on the fly, which is what Event Store can do really, really fast. And Eventuate IO does similar things. So the idea is my data state, my current state, is actually here and not in a projection at all. And so that's another very powerful model. Again, I have customers who are doing this with multi-region Amazon deployments, so it's quite robust, but it's a commitment. So, a lot of folks go with just the messaging route so that they can deal with, eventual consistency and projections that they know and understand rather than dealing with a completely new technology, because this is another piece of work, right? But both are excellent ways to achieve the same goal. Okay, so on that note, there's a lot of good information here. I mean, when I do a larger sort of implementation, usually we have everything from UI has, again, for the microservice vertical models that turn into commands. The commands call APIs. Those commands turn into multiple messages. The messages tie to topics or streams. Those streams are then projected to call additional APIs over here to finish the job. And all the things that are not gray are really sort of part of the single microservice vertical. But I may have other things on the outside that project additional messages that lead to other aggregate projections that serve other UIs or services that need to perform additional functionality across multiple service verticals that own their data. So anything that owns its data can still be projected as long as the messages exist somewhere in either a global topic that could be listened to or a topic that another projector can listen to and pull and build other aggregations. So it's really incredibly powerful. And I think the main thing that I'm trying to get across here is that it gives you that full audit trail. If you just start thinking, my service is manageable, I can do messages, now you've got your starting point. Once you have the data, you've got history built in, but you can deal with producing those projections later when you're ready. Then the potential for all these new views can come up, and you're not tied to the data model and the schema because you can project a new one from the messages in a different way that's useful to the next service without having got yourself stuck. I'm not saying you can't make mistakes and need to refactor, because that can happen, but it certainly gives you a certain liberation that I have found possible with this approach. You can add on to this with full visibility of all of your error messages and logs and successes and failures through the system, tie it to activities and messages so the messages actually correlate to all the things that happen from API to UI and so on. And I think at the end of the day, the barriers to this are always going to be cost, complexity, resources, and training. So it can't emphasize enough that if you choose something that's valuable to the business, then the business can get behind it, and you get your DevOps story, your DR story, your implementation story down, perfect it in a way that you can be resilient and recover from any failure, but also start showing business value early, because that's what's going to matter. It's all about the business benefits. And, of course, no pain, no gain. So with that, I'll let you go. And I'll be around this afternoon, so if anyone wants to talk about things we've done in production, I'm happy to have conversations today. Thank you.